Hi, in this video we're going to look at some applications of closures. And in this particular video I really want to show you how very often what you might write as a class can actually be written as a closure instead. So let's look at a very simple example, which is going to be an averager. We want something that will allow us to feed numbers over time, and it will just give us what the current average is of all the numbers we've fed through so far. So obviously a very simple approach might be to just simply store those numbers as we receive them and then calculate the average every time it's requested. So you might think of doing this using a class, and let's see how we might do that. So let's go ahead and create a class. Let's call it averager. And what does it do? Well, we're going to need an initialization. And all we're going to do here is we're going to create an empty list, numbers. So that's going to be an instance variable, numbers. Then we're going to define this add function, or this add method. And the add method is going to require the number that we want to add to our list. So we then would say self.numbers.append number, right? We've just added it. And instead of creating now another method to return the average, I'm just going to return the average. So every time we add, we'll get the new average back. So here I'm going then to, well, first I have to calculate the total. So let's do it this way. Total, I don't have to separate it out, but I'll do this just to keep it simple. So total equals the sum of self.numbers, and the count, which is the number of items, is just the length of numbers. And then we're going to return total divided by count. So that's our class. Pretty straightforward. It has one instance property, numbers, and it has one instance method, add, which appends the number to the list and then calculates the average and then returns it. But you'll notice that every time we add a number, we have to recalculate the total and the count. That's not very efficient, so we'll see later on how to make that a little bit more efficient. For now, let's see how this would work. Well, we could say A equals averager. And now we have a new averager function, a new averager object, right? An instance of the averager class. And now we can call add. So let's say we add 10. Well, our current average is 10. If we add 20, our current average now is 15. And we can add 30, and our current average is 20. Okay, so that works as expected. Of course, we can create as many averages as we want. So we can say b.add 10, and you'll notice that we get a value of 10. Yeah, because this b and this a are not the same, right? They are different instances of the same class. I'm just pointing that out because it's very similar to what we're going to see now when we rewrite this using a closure instead. So instead of having this class and kind of the overhead involved with having objects and initializers and so on and having the self, we're going to write it a little bit more simply. Let's go ahead and create a function called averager. And this one is going to have a local variable called numbers, and it will just be an empty list to start off with. Then we're going to create our closure. So now we define this inner function add, and add needs to take in a number because we want to be able to pass in that number. And what is it going to do? It's going to say numbers.append number. Okay? So this is no different than what we were doing in the class. We're just appending the number to the list. The only thing is that this numbers here is a non-local variable. There's no assignment to it. So add has a free variable, numbers, and it has a local variable called number. But numbers is the free variable. So now what do we need to do? Well, we need to do exactly what we did over here, right? So let's go ahead and do this. The only thing is we don't have self anymore. And that will work just as before. The only difference now is we have to return the closure. Don't forget to return the closure. Okay, so now we have that. We can say A equals averager, right? And we can say A10, right? We don't have to call add. We don't have to say A.add because remember, what is A? It is add. It's the closure, right? So A is 10. If we do A20, we get 15. A30, we get 20 back, just as before. And of course, if we create another, if we call averager again, we're creating another closure, a different one. And if we call B10, Well, we get 10 back. As you can see, the average, the numbers list is not the same between A and B. In fact, you can look at it this way, right? Here's the cell that A uses for its closure, right? For its free variable numbers. And here's the cell used by B for its free variable. You can see different memory addresses. Not the same thing. It's not shared. Just as we had, A and B were two separate, distinct objects, both instances of the averager class, but separate objects, we've got the same thing here. They both, if you want to think of it, instances of that closure, but they're separate closures. They're not the same. Okay, so now let's see how we can fix this up a little bit. Let me copy and paste this code down here so we can see it better. So every time we're calling the sum, right? We're appending the number to the numbers and then we're calling the sum. But what is the new total? It's the previous total plus the new number. And the count is the previous count plus 1. So instead of actually storing numbers all the time, let's not do that. Let's just store the running total and the running count. And then every time we add a number, we'll add the number to that running total, add 1 to the count, and then we can recalculate the average. Much simpler, and we don't have the overhead of storing those numbers and calculating the sum and length every time. So how would we do that? Very simple. We would say total equals 0 and count equals 0, right? So now here we don't have that anymore. Let me leave it in for a second. We have total equals total plus number and count equals count plus 1. Okay, and then we return total divided by count. Of course, hopefully you've seen that there's an issue here. We have an assignment to total. So total is a local variable. And that's not what we want. We want this total to be kept around every time we call add, right? We want it to retain its value. So we need to make total non-local. And the same thing with count. We need to make count non-local, right? We want that total and that count to still be around when averager has finished running and when add has finished running. Because the next time we call add, right, the next time we call that closure, we want it to remember what its previous total and count were. Hence why we're putting total and count in the averager body. But then we reference it inside the function, the inner function. And so we have our closure. Okay, so now let's go ahead and create an instance of that closure. So A, again, is just a closure, right? So it's this function. But now you'll notice it has two cells that it's working with. Yeah, that's because it's working with two free variables, right? Count and total, right? At these memory addresses. So now we can call A 10, we get 10, A 20, we get 15, A 30, we get 20 back, right? Same as before, no difference. And of course, if we create another instance of the closure, we'll start a new running averager as well. So in general, you can always do that, right? We could have written this as a class as well. Very quickly, let's take the original class that we had, right? We could have written it this way. So let me insert it up here. And instead of storing numbers, we could say self.total equals 0, self.count equals 0. And here, of course, we don't do that. We just say total equals self.total plus number. And then, of course, this is self.total. So I don't want to keep rewriting self all the time, so I'll use the plus equals, but remember that's kind of what it's doing anyways. And count plus equals 1. Okay, and again, self.count. And then we're going to return self.total divided by self.count. So these two things kind of do the same thing, right? This uses a class to store total and count in instance properties, right? And then this add method uses the instance variables, total and count, the instance properties, to calculate and return the average, right? So it adds the number, calculates the new average, and then we call it again. So we've done the same thing, one using a class, the other one using a closure. So pick whichever one you prefer, but very often writing things as a closure is sometimes easier and has less overhead than using a class, but it's up to you how you want to do it. Now let's take a look at another example, which also shows you that you can take a class and rewrite it as a closure. And in this case, I really just want something very simple that's going to allow me to count the number of elapsed seconds, right? So, and we know that we can do that using the perf counter. We've seen that before. That's in the time library. So from time, import perf counter. Import perf counter. The function, I want to call it. Not yet. So now we can call perf counter. And perf counter returns some value. Don't worry about what that value is. It's kind of meaningless. For our purposes, we just want to know the difference between two consecutive calls to perf counter. And that will give us the elapsed time between the two calls. So we look at 2095 minus 2082, forgetting the decimal dust. So here we had approximately, 13 seconds elapsed between me typing this and running it and me running this one here. So that's what we're going to use perf counter for. So let's start with maybe a class. Let's call it timer. And we're going to define our init function. And it doesn't take any parameters, but it's going to store the start value. So it's going to start basically whenever we first instantiate timer. So when we create the class, when we create the instance of the class, we're going to immediately take what is the perf counter value. Okay. And then here, maybe I'll call it poll for now. I'll change that in a few minutes and show you why. So poll self, it doesn't actually take any parameters. And what is it going to do? All it's going to do, it's going to return the current perf counter value minus self.start. And that's all it does, right? So basically now I can say t equals timer. Let's call it t1 equals timer. Okay, and now I can call t1.poll, right? T1 is the object, the instance of timer. It has a poll. Now it's already been counting, right? Because as soon as I created T1, it ran perf counter. So now I look and 15 seconds have elapsed. So that's how long I talked between running this and calling this. Okay, so now we can again call it again. T1, call it again, and .poll. And now we get 32, spoke another 15 seconds. Now we can change this into a closure, but before I do, I just want to show you something that's interesting. You notice how I have to say T1.poll. I've got to call this thing, but really every time there's only a single function I'm interested in. And so what I'm going to do, I'm going to change this to a special name, dunder call. What this does, all this does, it basically says to Python, hey, the object that you get back after you've created the class is now a callable. And when you call it, just call this method over here. That's all it does. So now I can say T1 equals timer just as before, but there is no poll anymore. So now instead of calling the poll method like I had before, right, there is no poll method anymore. I'm just going to call the object. And it returns the elapsed time between when I created this and when I call this. And I can call it again, and we get that. So this is nothing really very fancy. It just says that the instance that gets created from this class is a callable. And when it gets called, right, by putting these parentheses in, it's going to call this method over here. And we'll see that in more detail when we get to object-oriented programming later on in the course. Okay. So this really has nothing to do with creating the closure. I just wanted to show you that because sometimes it's useful and makes your code a little cleaner. Okay, so let's now go ahead and create a closure that would do the equivalent thing. So we're going to create a function, def timer, and here I just need to store the start, right? I need to store what is the start value of this perf counter. And then inside, I'll call it poll. Doesn't really matter since we'll never refer to it by name. But here's the poll, and what is that poll function going to do? It's going to return the current value of perf counter minus start. And then we have to, of course, return our closure. And that's it. So these two things will do the equivalent work. So now we can say T2 equals timer. Okay, so now I've got T2, and I can call T2. and I get that. And I can call T2 again, and I get it. And that's why I wanted to call this under call, because the way you call this and the way you call this is identical. You'll notice there's no difference. I can say T1 and T2, right? But T1 is using the class, T2 is using the closure. So in general, you'll find that when you have classes that are pretty straightforward, there's only one call you're interested in, and even if you have more than one value being stored, as we saw with the count and total, you can rewrite it as a closure. And oftentimes the code will be simpler. All right, so thanks for watching, and I'll see you in the next video.